Hi, I'm John Zawiskie. I'm the geologist and paleontologist here at Cranbrook Institute of Science. I'm in our Explore Lab at the present time, and what we're looking at here is the bedrock of Michigan. These are the fossils you would find underneath the glacial sediments, right underneath the museum here and in many places here in southeast Michigan. Beneath the glacial sediments, there is what we call an unconformity, a gap in time. And so once we go through the Ice Age sediments, we jump back 380 million years to a time period called the Middle Devonian. And unfortunately, it was 380 million years ago because it was like the Bahamas are now. And how do we know that? Well, fossils. What we're looking at here, you may recognize these fossils. Anyone that's collected a Petoskey stone along the shores of Lake Michigan or Lake Huron will recognize this right away. These are rugose coral mounds, and each one of those little depressions would have a coral polyp living in it. And they would secrete calcium carbonate and build their reef structures up off the sea floor. In addition to this, we had fossil sponges and also solitary corals. So rather than having a mound, there would be a platform for a single coral polyp to live on top. So this one in particular is kind of interesting. You'll notice the banding that you can see in these corals. If we section them and look at them with a microscope, we can recognize yearly bands, monthly bands, and daily bands. And what this tells us, these corals tell us that 380 million years ago, there were 410 days in a year. The Earth the rotation of the Earth has been slowing down as a result of the tidal interactions with the moon. So you could get a lot more done in a year back then. Just kidding, of course. Okay, so this would be a solitary coral with one polyp on top, and commonly when storms would knock them over, they would grow up toward the light and reestablish the polyp would reestablish itself here. So you see them doing some really torturous things in some of the examples, meaning that they got knocked around on the seafloor and rolled around. Now, these are called rugose corals, solitary rugose and rugose mounds. This variety is referred to as a tabulate coral. So there were two distinctive corals. This was a true colonial structure. These are sometimes called chain corals. So the little polyps would live in the little depressions along these links. And when sediment would bury them during storms, they would grow up out of the sediment. So the sediment then became part of the coral reef edifice. So the chain corals, there's another variety of tabulate coral. Again, very little depressions here for the corallites. And these, along with the rugose, were the main reef builders during the Middle Devonian, during the shallow tropical sea environments here. Now, this feature on top of this sequence of rock, this is a fossil sponge. We call them the stromatoporoids, and they perform some of the functions of green algae and such in the modern reefs. After storms, the sponges would become established over the seafloor rubble and stabilize it. And this would allow corals then to come in and reestablish their growth on the seafloor. So they were very important for that reason. So the stromatoporoid sponges, the rugose and tabulate corals, these were the primary Middle Paleozoic reef builders. Okay, now some of the other organisms that were on the seafloor at this time, lophophorates or brachiopods. These would attach to the seafloor and filter food out of the water column. Many organisms were filter feeders here. Gastropods and other large gastropods and smaller snails. These would graze algae off the seafloor. Sometimes the shells of the brachiopods would dissolve and be replaced by pyrite. So these are quite beautiful pyrite iron sulfide replacement of the original shell material. Now coming along toward this end, these are trilobites. These are arthropods that lived on the seafloor. They had one of the longest ranges of any animals in the rock record. They made it through just about the entire Paleozoic era. You see a cluster of them here. This isn't hydraulic sorting or anything. This is actually what we call a mating cluster. So they would get together like this. I like to call this Devonian spring break right here. Little humor there. And so the trilobites were critical animals for eating organic matter off the seafloor. This one is particularly interesting. The burrow underneath it is filled with pyrite. A lot of times there would be reducing conditions in the sediments, and parts of the trilobites themselves would be replaced by pyrite. This is a burrow just beneath this trilobite. You can see they had compound eyes, very apparent here. This is Wallicerops. This is a relatively new addition to the CIS collections. And the trident out in front is most bizarre. People have a hard time figuring out what its function was. Species recognition. My own preference is possibly this was for rooting out organisms in the sediment that they may have fed on. And then finally, we've got some of the first free-swimming, in fact, they were the first free-swimming predators in the world's oceans. These are called Nautilusoids. So a squid-like animal would live in the last chamber, and these, as I noted, were the first free-swimming predators in the oceans. Fish came in as predators after development of jaws in late Devonian and Mississippian time. So the next time you're out at Point Pelee or somewhere where the bedrock's close to the surface, you'll be able to find fossils like these, and along the shores of Lake Michigan too. Storms will break up the bedrock offshore and wash them in. Of course, we've all collected Petoskey stones on the western coast of Michigan. Sometimes we can find them in places like Alpena. There are quarries that you can go into north of Alpena. Especially, I like to recommend Rockport Quarry for that function. So this is what the world was like. Much of the Earth, oceans covered much larger areas than they do today. The Earth was pretty much uniformly warm and subtropical during this time period. And these rock layers are routinely mined. We call it limestone. And of course, it's a key ingredient in concrete. So I hate to make concrete out of these beautiful fossils, but many of the carbonate rocks are mined for that reason. And some of the organic matter in the rocks have yielded gas and liquid petroleum too.